So there's going to be 20 minutes of initial talk. Each session is basically going to be 40 minutes. That's 20 minutes of talking. Then for the second 20 minutes, we're going to try to focus on the three most important takeaways and that you had from the 20 minutes. We're going to 20 minutes of those, and then at the end of that 40 minutes, we're going to report back, and every group is going to report on one of those takeaways. Christopher will walk us through all this. Don't worry, you don't need to learn much. This will all be handled by facilitators. But please, if you're interested in either being a facilitator or a scribe for a topic table, volunteer to do that. A scribe, by the way, doesn't have to write everything down. You're basically trying to get the main points. Speaking of scribes and facilitators, we have Sita Mag. She is our graphic facilitator. Thank you to Blockstream for providing this. And Sita was really picked, and she's going to visually capture the key ideas that happen here in the plenary. So there's going to be the plenary stuff where everybody's involved. There's going to be the breakout stuff. She's going to capture stuff for the plenary. Media, privacy, etc. We are going to have some video recordings. So if you don't want to be on video, respectfully, don't get in front of the video camera. If you don't want to be recorded, then avoid being recorded.
It will be pointed at the podium.
It'll be pointed. I'm looking at you right now. This is the only place that's going to be recorded video-wise. If you're interested in doing little, DASA sometimes does little interviews. If you're interested in being on a little video thing, come talk to DASA. Speaking of interviews, Bailey, are you here? Bailey Reutzel is going to be here. She is a reporter. She's done stuff for, is it Coinbase? No. Yeah, she's done things. She's a freelance. CoinDesk, thank you. CoinDesk. She's probably going to be doing a couple of interviews. If you're interested in being interviewed, you can talk to her. Otherwise, she'll talk to her. She has made sure that she will not quote anybody unless they give her permission to be quoted. And speaking of quoting people, social media, the hashtag for this event is blockchain web. Please do not quote people out of context. This gets you in trouble, and gets other people in trouble, and it's embarrassing. Let people know that you plan on tweeting about them. If they said something that's not here, I feel it's fair game. Say something, please ask them before you tweet it. Follow the golden rule. Tweet others as you would want to be tweeted yourself. Just be careful that the things in here don't spread out of context elsewhere. This is obviously a public thing, and it's meant to be public, but we don't want people to have to defend something that they said in this room in the larger media stage. Okay, why we're here is an opportunity for collaboration. W3C wants to know if there's anything that is ready for standardization, if we have a role for that. Is there any way in which the blockchain can help the web and web standards, or vice versa? Is there anything that web standards can do for blockchain? That's what we're interested in. There may be other things that come out of this, other collaborations that you have that have nothing to do with standards. That's great. We're glad you're here.
Somebody asked me to talk a little bit about
standardization value. Like, how do you go about standardizing things? I'm not going to talk about the process. When you talk a little bit more about the process, and about W3C in general. When is something ready for standardization? Is there a clear problem statement that this would solve for a significant number of people? That's maybe an indicator that there's a value in standardization. Is there a good starting point? Is there already an implementation? Is there a spec? Is there a clear solution? Or are there a set of convenient solutions? That's also good candidates for standardization. And do we have the right stakeholders? In other words, are the right people ready to come to the table at that time? And are they ready to implement things, test things, write, review, etc.? Are they ready to deploy this thing? If none of those things are true, it's probably not ready for standards. If all of those things are true, it might be ready for standards. W3C focuses specifically on three main things. We focus on client-side features, browser-based stuff, markup languages, JavaScript APIs, user-facing features. This is our main focus. This is what most of our stuff is. We also do stuff around data formats, like interchange formats, ontologies, vocabularies, languages to manipulate data, etc. Just as a caveat, a lot of the browser vendors steer very far clear of these things. So if you want to get involved in those, it's a good idea to talk with browser vendors first to make sure that that this is something they're interested in. If it's something that's going to touch on browser client-side stuff at all, it's probably a good idea to get browser vendors involved earlier rather than later. It has to touch the browser. We also do communication protocols. We do those more rarely, usually only when there's a client-side API. For example, WebRTC, there's client-side APIs and there's stuff that there's protocols, and usually we partner with the IETF to do stuff like that. So there's lots of W3C staff here. Will all the W3C staff stand up? So I see Jeff Jaffe back there. Jeff is our CEO. I see Alan Berg. Alan is our biz dev guy. If you want to join W3C or give us lots of money, Alan's the guy to talk to. Son is a guy working on Solid and some SimWeb stuff. Formats. And Wendy Seltzer is the head of technology and standards domain. I'm Doug Shepard's jack of all trades, master of nothing. And so I want to thank our sponsors, Daza and Neha, here at Media Labs, Professor Sandy Temple is providing space. NTT, do we have NTT here? NTT is over here. They're going to be doing a demo over at this table. I invite you all to go see the demo and talk to them. They can do individual demos. Thank you very much for your sponsorship. All of our sponsors are making this possible. Blockstream, a graphical facilitator. Generous WTC members have provided funds for this. Meals. We have twice the number of planned attendees. We've got meals for everybody. Thank you again to the sponsors. Everybody gets the sponsors at hand for providing. We try to get meals for everybody. If you did not register in time, you might not get a meal. If you don't have a badge with your name printed on it, respectfully, ask people, make sure that the people who have, who put in the effort to get involved early on, make sure that they have their meals. There's vegetarian, vegan, gluten-free meals. Please do not take food that you didn't ask for. Vegetarians, everybody eats vegetarian food, so don't take one of the vegetarian boxes unless it's clear that all the vegetarians have already gotten their food. I'm vegetarian, and I will eat humans if it comes down to it, so don't push me. If you had a request for a meal, come to me at the thing. If we're not able to feed you, I apologize. There are food trucks right around the corner there. Really good food. That's what I only eat food trucks here. We probably have food for everybody, but I just want to make sure that the people who had food first. Another thing, apparently there was some food over there in that area. Please do not take the food that's out there. All our food will be in here. That is for a set of other people. Only take the food that's in here, please. And all your trash, there are 3 bins back there. There's trash, recycling, and compost. Please bust your own tables. If you make trash, put it back there. Thank you. That's it. Thank you for attending. Treat everybody respectfully. Have fun or don't, whatever you prefer. If you have any problems, either here or outside, if there's any issues, contact me. This is my phone number. Any troubles that you're having, let me know. Okay. And with that, I'm going to turn it over to Wendy. It's going to take us a moment to get her slide set up. And thanks, everybody. Any questions, comments?
What's the hashtag again?
Hashtag is blockchain web. One word. How about blockchain on the W3C channel? On the W3C. IRC.w3.org. Hashtag blockchain. Hashtag hash blockchain.
While I'm getting set up, I might invite people to join the irc.w3.org proceedings. Fantastic. So thank you all for joining us here. It's really great to see such a large crowd to join us in thinking through what blockchain, the technologies, and the industry interest and the technological development mean for us here at W3C and our work in standards. So why do you come to W3C? Well, our founder, director said it best when he tweeted out at the London Olympics, this is for everyone. We are working to build the web into an open platform that is available, accessible, globally interoperable, and usable by everyone. And so if you have technology that you want to work on that global open basis, in a distributed manner, then the web is the platform on which to do that. And W3C is the consortium and standards body that works to help keep the web open and help to build the consensus on which the web is founded. We don't have police power to compel people to obey web standards. What we do is to build consensus through W3C process and with our open royalty-free patent policy to invite people to work together. And so we have more than 400 member organizations who send thousands of participants to working groups, to community groups, to interest groups, to work together. We have a relatively small staff to work with all of those people, about 65 members of the technical and administrative staff, working to facilitate that consensus. We work in working groups. Are the groups that develop the recommendation track standards. We also have interest groups and community groups that work at the earlier stages of development, use cases and requirements, generating ideas, helping to incubate them toward the standards process. As I mentioned, we're governed by process documents. Our Constitution sets out the ways that we work and bring people together, and we rarely take votes, and we much more often are engaging large groups in debate and discussion, and to figure out what can we live with, what can we all live with that will enable us to work together. So here's a rough and barely readable diagram on PC of our standards development process. If we start from the bottom, we are in the very early phases of thinking about blockchain and thinking about the technologies
that
that work together.
we start
In our investigation of technologies, often with workshops and community groups, to brainstorming, thinking about what does the web need, what does the technology need, where are places that our public and our membership can work together with the help of our technical staff, that we can help facilitate working together. And possibly out of that comes the formation of a working group. Possibly out of that comes great conversations that start up around tables here and go off and form technology startups, or go off and
form academic
research projects, or go off and incubate in industry or in public interest organizations. One possible development there, though, after that incubation happens, after people say, you know what we really need to work together is a common interface, a common API, a common format. When we have that level of clarity, we might form a working group. Working group iterates on the proposed standard, sends it out for public comment, invites comment from its participants, moves up the recommendation track, and after consensus is reached in the working group and among the wide review from the public, that might be published as a W3C recommendation. And that's not saying, again, that we know of any particular recommendation that might come out of here, but if we find something, that's where it will go. So what are we thinking of more particularly here with the blockchain labs? Well, there are two different ways the blockchain and web standards can work together. We can think about what does the web need to add in order to support blockchain better, and that's possibilities like crypto, formats, APIs that could be added to the web to make it easier to access the distributed ledger universally, any place you have a web browser, easier for the web to interface with those distributed ledgers. And then conversely, there are also opportunities in how can the technologies of blockchain support the web. So for example, distributed ledgers supporting certificate transparency is an effort that's underway at the IETF, storing the record of certificate issuance on a ledger publicly, transparently, so that anyone can check for certificate misissuance. And so, as Guy mentioned, some things are right for standards, some things are too early or not yet standards ready. Standards are great for improvement, harmonization, and consensus. When there are already multiple examples of the way something might be done, and we need to smooth the corners or fit the two or three or four of them together on the same framework. When there are already working examples from which to derive a consensus, patterns to match, to bring to standard repertoire. Standards are less well suited at the beginning of the innovation process. There's lots of new ideas going on. We don't want to lock anything into a standard. We're not yet ready to say, yes, this must be the block size, or this must be the format in which things are expressed. While innovation is running, that's the great time to be incubating possible standards and identifying places where you might need coordination. Not yet the time to write it into This is a global recommendation for the web. So I wanted to briefly mention some of the work the W3C is already doing that might be relevant to work that you're looking at. So we in the security and privacy area, we have work in web authentication. I see co-chairs of that group here. We have work in web crypto. We have web application security, payments. We have privacy interest group. We have payments both an interest group and a working group. And then in the broader web, we have HTML being worked on in the web platform working group. There's work on web performance, CSS, HTML media, WebRTC, real-time communications. There's graphics, there's audio, there's fonts, there all sorts of pieces. I wanted to dive into a couple of them in a little bit more detail. Web authentication is one of the newer pieces of work that came over to W3C from FIDO Alliance. Username and password is a terrible way to authenticate. If we do it everywhere on the web, how can we get beyond that and make strong crypto the basis of all of our web authentication? So the Web Authentication Working Group is building the web APIs to act as the interface between the local authenticator, the web client, and the relying party, specifically where that big arrow is between the local client, which might be a web browser on a mobile device, a web browser on a laptop, and a website relying party. So this will be one module of a larger authorization framework. We're building a way to do strong authentication from the web client. Another piece of work that is in its candidate recommendation phase is the Web Crypto API. So instead of inviting every web developer to write his own or her own JavaScript crypto libraries, we're building an API standard across the browsers. Rather, implementers are building the implementation. We are standardizing what that API looks like so that a call to encrypt or decrypt or verify produces a result cross browser. So this is a place where if there are specific crypto functions, specific algorithms that you need for blockchain operations, an update to the work of the Web Crypto Working Group could be a good interface for that. The moment we have a set of standard curves and algorithms, and those are being tested for interoperability and moved forward toward recommendation, but the API is extensible, and if there are additional algorithms needed, this is a good place to build for those. Lots of work in our Web Application Security Working Group. If you're building web applications and want to assure that others aren't injecting in cross-site scripting attacks and data theft attacks, the various APIs designed in WebAppSec help to secure web application, make it easier for the authors of web apps to deploy securely and rely on the transform layer security of HTTPS. Again, places to think about if you're developing applications in the browser, looking into WebAppSec APIs and designs. And support for encryption everywhere, because we believe that a strong web is one where people can rely on end-to-end security and authentication and integrity protection. And so we support HTTPS with browser side features. And We have web payments work that's building up a payment request API, and that's looking across payment types. And so if you're here because you're interested in Bitcoin or cryptocurrencies, look into the web payments work to think about whether that is extensible in the ways that you would need to support current alternative currencies, whether it by default the protocol will support payment, and does it include the payment features, or is it extensible to include the payment features that that you might need for the cryptocurrency? And along with the basic payment request API, there are payment method identifiers, basic card payment, and progress on payment applications to support that API. So I'll put this up on the web with links to the various pieces of existing W3C work, and invite you to think about that as one template for the way standards work can happen, one interface for kinds of work that you might be doing. But most of all, I want to invite you to share ideas and thoughts about work that maybe will pre-standards phase right now. Think about W3C as a big tent in which you can have conversations about that work and come back to our recommendation track down the road when you have something that looks standards ready. So thanks very much, and thank you again for coming to share your ideas at this workshop.
Good morning. Good morning. My name is Christopher Allen, and I'm going to be handling the next session, which is about collaboration. But first, I'd like to do a little housekeeping. So we're going to be distributing some stuff onto the tables, but the other thing we need to do is distribute some people. So I'd like everybody to stand, give yourself a stretch, a wiggle, look at your table. If you've got 7 people at your table, I need one of you to move to another table. Okay? You want 6 people per table. Well, in my rough count right now, there are some tables over here that only have 3 people. There's another table here that only has 3 people. There's some space over here. If you've got space at your table, raise your hand. So there's some space there. Okay. So you've done with your wiggle, and you've got enough people at your table, and ideally every table should have 5 people, 4 or 5 people, not 3. Okay? So that's the other side of things. If you're at a table of 6 people, and you see a table next to you that's only got 4, you may want to consider moving over the table 4. It'll give you more time to speak. Okay? So I see a table here with 4 people. I see a table here of 3. You come over here. Okay, so we have a table of 4. So 20 minutes divided by 4 gives you more time. You can have 4 minutes in that time rather than 3. Okay, so the goal of this session is to share stories and lessons around collaboration. So the cards that I'm handing out right now is a distillation of over a century of facilitation work. These, over 50 facilitators got together and looked at what were the patterns in common for the best events, the best collaborations that they were involved in, and distilled them down into 91 patterns of what makes for a great, wonderful, magical collaboration. So everybody's going to get one of these collaborations. You can either, once all of them are passed out, you can either grab one randomly, or you can pick one of the set. And my suggestion is that when you're done reading it, put it in your badge, behind your badge. So I would like you to be the avatar for that particular pattern for the rest of the 2 days. I'd like you to think about what it is that is this particular pattern of greatness, and see if you can't embody it or recommend it or find it in the next 2 days. So for the next 15, 20 minutes or so, I would like each of you to tell a story about a collaboration that was really meaningful to you. You know, it can be a business collaboration, a standards effort that you worked on. It can be another team in your company, or it could even just be a personal collaboration that you just found really, really powerful. I'd like you to share about 3 minutes of a story about a collaboration that you found very, very powerful. So the time is now 9:23. So let's try to do this in around about 15 minutes. So it's a 5-person table. That's 3 minutes each. That's next round.
These are not for now, though.
I think it's for now.
Oh, yes. So I think the exercise is we look at the cards and that we share with each other when we successfully collaborated with other organizations. I think?
Yes.
Okay.
Okay. The story doesn't have to focus on the card, but it is more. Think of yourself with that avatar for the next 2 days.
Any thoughts?
On
Yeah,
successful
maybe
collaboration.
What kind of operation?
You mean thoughts on successful previous collaboration?
Yeah.
Just you want to share it? Is that the objective?
Yep.
I would
It is.
say so. My most recent successful collaboration is our blockchain startup inside of Microsoft, where basically everyone involved in the project has opted in to the success of the project, whether or not they were authorized to do so.
Cool.
And so it's created a very fulfilling across the company, across many different groups, a virtual team that is basically collaborating on moving the ball forward in lots of different categories. And
they're all encapsulated in this one point. The last event, the beginning where was that. I will not name the people that told me this lesson. Hello, Manu. And the point is what to achieve collaborative consensus. So people throw a lot of ideas on the table, and most of the times we just talk, we go in different directions, and the group misses the actual focus. And so there must be one person that accurately, there's a lot of knowledge about the problem, that writes down a summary of each different point and makes sure that it's going to stop all the conversation that is happening to make sure
all have reached agreement, at least in some of the points that he summarized. So it's very important to sometimes stop for 1 second and list the set of things that we've been discussing to see where is the agreement and where it's not, and how to move forward in these points.
It's also, I think, important to have someone who is able to listen to all ideas and maybe summarize them for the rest of the group, because I think a lot of times we don't use the same language and we don't understand what other people are saying, and because we don't understand it, we don't process it, we don't internalize it, we don't accept it. So it's good to have one facilitator and we have drawn ideas rather than summarizing it. Then we can have a transparent way of maybe voting and deciding what's the future. So collaborative consensus is something else.
Friction with respect is productive, and we were trying to come up with a story. We were thinking of like rock bands, the way they as a band comes together, the creative tension of each individual member remains the case to the other. They write these hit songs. Often when they break apart, the lead singer songwriter just doesn't have the magic. So there's just a healthy amount of friction is actually good.
So I'm in table 3. So in my previous life, before I entered this crazy blockchain space, I used to work as a consultant for McKinsey, and one of the things they were really good at is teaching you proper processes, I guess. So one thing which I learned during a training and that we agreed on in our group also is, which is quite important, is a shared problem statement. So that's an evolving kind of document where you first of all spend a lot of time to formulate like an actionable, measurable problem that everybody agrees on, but then also like the measures you have at hand to solve that problem. So so that's one thing we thought at our table is very helpful to actually make sure also that what you do is or what you come up with in the end solves the problem you agreed on in the first place.
I'm at table 4. So we talked about a lot of things about the mechanics of collaboration and how you make things work while you're doing them. But the thing that we thought was most important to share actually is that it's really important to recognise when you've finished or when to stop. And we've all, I'm sure we're all in other groups and other areas where either something's failing, it's never going to work, and everyone's just flogging it, or we did a good job, but now that thing's finished, and that standards body we didn't need to hire 20 people to work permanently because the job's finished and we should go spend our efforts somewhere else. So we didn't need a special antidote because I'm sure we all have at least one personal one from work or private relationships. But knowing when to stop, when to regroup, and when to go do something else is actually really important to maintain healthy collaboration.
Okay, we're table 5. We kind of synthesized the 3 good ideas into one super secret sauce. And so our story is several decades ago, there was a guy, and he was like, "We're gonna go to the moon," and they were sort of rivals with this other team that also wanted to go to the moon. And so that's one of our aspects was sort of this collaboration versus competition thing. And then you also want sort of this cult-like aspect of collaboration, where everyone's united against a common enemy and has sort of this motivation that's sort of above and beyond. And then you achieve that. So they actually, the story is they went to the moon and it was pretty fun. So those are sort of our aspects. Is you want competition and collaboration really go hand in hand. And in a lot of cases, you kind of want motivation that is not maybe rational. And I think that's pretty common in a lot of technology, blockchain, or as I call it, Bitcoin, especially, that people are kind of crazy about it. And I think a lot of, I wasn't necessarily around with the first web standards, but I bet there's a lot of crazy people who are like, no, it's got to work this way. So those are sort of the secrets.
Table 8. So our top 3 were having a common goal, obviously. Flexibility and diversity, I don't think has been mentioned. So having diverse teams where people bring different social skills and different technical skills to the table. And then our final one, which is the one we want to emphasize the most and tell a story about, is trust through facing common challenges and having a common mission. And Gladys has a little story.
Hi. The story I want to tell you is fundamentally a story about trust. It happens right here at MIT about 5-6 years ago. In the winter, a very, 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 very famous professor was prototyping a class, and there was going to be a week workshop, and then 2.5 days, 3 days hackathon at the end. And as we were propping ideas to what to do for this hackathon, there was 4 people that couldn't find a place, and it is a large group. And one of the facilitators talked to one of the 4, which I was one of the 4, said, "You know what? You 4 are like misfits. I'm gonna put you 4 together, and let's see if you guys gel." And the 4 of us were like, in the size we never met before. We just walked down a corridor on building 26, and I said, "Let's get together in a particular place, and let's talk." And I said to them, "If you guys trust me, I'll trust you. I don't leave anybody behind." And there was one person who was a former naval officer. He said, "Well, that suits me. I don't leave anybody behind." And then it sort of became the team. And we sort of have all sorts of breakdowns, servers that break down, and data that we thought we had going to help and we didn't. And then people bailing out the team. And we worked like maniacs. I don't think I have worked as that hard. And we finished our project at the last minute. We were in the blue room when everything clicked. And we went in, and it's very large groups. There were just the 3 of us, and everybody thought they wouldn't have anything. We got it, and it was just a trust that made it work. And we sort of walk away of our egos and everything, and we had a common goal. And I think when we got a common goal and we wanted to work, it works.
So our secret sauce was fail fast but stay focused. So the idea was that when we can prototype at the proper time, we can continually create consensus that is more grounded and create projects that are more expedient and focused.
It's a prototypical story where one organization has got the responsibility to sort out the problem for customers, but there are other organizations also involved in that problem. So the
issues that that sort of can get jammed and never get through to be resolved. So in this case, the organization that closest to the customer takes ownership of the problem, and they decide to, in order to make it, to explain it to and communicate to other organizations, to break down the problem into manageable nations, so that they break down data silos, and then they're able to present those data to third party and which breaking down of information and also taking ownership of the issue.
This is number 9B. See the 2 9s. So ours is focused more or less on sidestepping proprietary interests and stale thinking. And there were a couple of examples. One was from the degree, the MIT has got a blockchain-based degree issuance here, and the way that collaboration came together. It was critical that nobody owned the result. And that's also the experience that I have had in trying to bring together essentially legal and tech, and their endless conversations with various groups who do have ownership interests proceed very slowly, and then suddenly a small group of students in a Paris law school just picked the thing up and they taught it to themselves, and they're now charging ahead. So they don't own any of the ecosystem yet, so they're not inhibited by the problem of who owns. I'd like to just make one point, which is it might be, as I think our keynote speaker has commented in a wonderful tweet, it might be that what blockchain solves is that ownership problem. That is, it's a way for folks who ordinarily have got vast vested interests to collaborate with one another without a concern about who ends up owning the ecosystem.
So table number 10, as far as I know, it's the only table number 10. Our takeaway is encourage early adopters through hands-on play. One of our user stories was SVG, for example, started off in 1998, but nobody was using it until 2010 because it wasn't in all the browsers. But before it was in all the browsers, it was an Adobe plugin. And that Adobe plugin let a large community start to play with this and to see, actually, it's visual, so you can see what you were doing. You change the code, you look in the browser, you can immediately see your changes. So that encouraged a lot of play and a lot of experimentation. And if it weren't for that early phase of having that plugin, that thing that worked in the browser that everybody could use, that was widely deployed, it wouldn't have had any legs to carry it forward to the long slog of getting it in every browser. And then another user story that was shared at our table similarly was your first Bitcoin transaction, being able to do that first time is really an empowering experience. So basically, letting people play with the technology, putting it into their hands, having something that they can viscerally experience for themselves is a really important part of building a community around adoption. Morning, everybody. Table number 11. One of our key points was talking does not equal communication. I see a lot of familiar faces in the room, and I know some of you well enough to know that you hope that I finish this as quickly as possible. And I've been involved in a lot of these groups before, and a lot of times people talk just to talk because they want to feel a sense of participation. But all of our time is precious, and everybody here has specialized knowledge. And if you don't have specialized knowledge about a particular area that people are talking about and they're making progress, then it's sometimes good to exercise restraint and allow that progress to happen rather than just to participate. You can find other roles than to be able to collaborate and communicate.
that are productive. And so if you feel like you're being left out or something like that, but everybody's making good progress and you want to participate, that's often a good human instinct. But just try to recognize the balance where your own desires are holding back the ability of the group to make progress. Thanks.
Hi, Table 12. We were talking about maintaining the distinction between deliberating on a solution and actually coming to a consensus on what that solution ought to be. And often those two are confused, and people will try to push to finalise something before it has been fully deliberated. So, for example, you might look at the debates about block size. More topically, so I'm from the UK. If you turn on the news, you may see something about the dangers of voting before you deliberate fully. So,
Hi, we're table 13. So I wanted to start with a story. So I work here at the Digital Currency Initiative at the Media Lab, and we're a really interesting group because we have computer scientists, former journalists, a politician, ethnographers. We have a really interesting mix of people. And the story I wanted to share is about how someone was presenting an idea once in a meeting, and the computer scientists immediately started finding security holes in what they were talking about and problems. And this really offended the person, and the computer scientists were like, "Well, this is what we do, you know? Like, we're talking about your idea. We got to find the rough edges and stuff." And so I think Aline's going to share the point from the story. So.
So I think the point is that setting up the conversation is really important. So, for instance, in this case, I think it's very important for the journalist, or the political scientist, or whatever type of research this person is doing, to understand how we're going to communicate in this meeting. So, for instance, if I'm a security researcher, I should tell these people that, hey, there's going to be a point in the conversation where I'm going to put on my security researcher hat, and I'm going to attack your idea as a security researcher does. Similarly, maybe it's also worth, for instance, putting a nice person hat before you put your attacker hat on, sort of to recognize the interest in this behind the idea. And I think that helps build consensus about what people actually want to get up to. So that's kind of the point. Setting up the conversation might be very important. And these assumptions like, hey, I'm going to put this hat on, are really important to send across.
Hello, I'm from table 14. So our secret sauce is diverse groups finding common ground through mutual discovery. And part of that we thought about emergent behavior, the whole being greater than the sum of its parts. So in that sense, you think about a beehive has a lot more resources at its disposal than the individual bees. One of the things that we talked also about was connecting to impact, and that speaks to having an end goal of some sort in mind that you're going to achieve. Part of that way of achieving those things, we think, if influenced by default to being open, is a good way to go. We had a few of us spoke about our different areas, one of which was always having an open door policy, literally. Another was one of our individuals had the opportunity to have an open forum where artists as well as engineers were both invited, so there's some diversity there. Also, I think that's probably about it. Just having diverse groups finding common ground, mutual discovery, defaulting towards open for an end goal of having some connecting by impact.
Hello everybody, from table 15. We talked about a great number of topics, diversity, openness, anyway, the story we want to tell you quickly about as short as possible is at Samsung 2 years ago, we tried to solve web payment solution for merchants, so making web payment as much as possible, less dropouts, all that stuff. So now because of the business interest, because it's one company, right, we had a big backing of a bank and Samsung Pay is the payment option from Samsung. We tried to solve the problem proprietary for that bank and Samsung Pay. And it solutions there, but after a few years in browser, I learned that proprietary solution for web it's not good. So then we joined W3C Payment Group, shared our experience, and just in year 8 months, 10 months, just having more diverse group, looking at more eyeballs, trying to solve the problem, more use cases, effective collaboration. It just blew up my mind. It's just the best way it could have happened. So no matter what, they came up with a conclusion that openness is the way to go. That's it's a great source of the. Thank you.
Hello everyone, I'm Ravi from Table 16. Our secret sauce was open communication and listening to one another. In fact, the team was actually building out on other people's stories, so the collaboration worked out very, very well. We had Shippy talked about the red and green flags in IDO, a story where you would give negative feedback as well to build consensus. We had Wendy talked about going into details and getting down to the modular level that really matters. And once you get there, you'll be able to build the consensus. That's how W3 operates. We had Sanjeev Narasimha who talked about his experiments with crowdsourcing and how he's trying to build that out in terms of building a larger sense of consensus all around and getting that in the crowdsourcing platform. We had Deb talked about getting the context in, and that context piece will help people realize what exactly they're trying to agree upon and build that context. With that foundation, you can actually build on the agreement. And we had Daryl talked about do the pieces and some of these things that come about. You start the experiment, you do it, you will learn more from it, and then you will build out on that experiment. So he calls that W3C. And finally, we agreed upon the storyline of a milk cooperative in India, which is called Amul. And here you have to build consensus among people who are actually illiterate, and they used to sell milk individually. They had to agree and get together across farms, across villages, and across various towns to build out a cooperative society that would work together with each other, preserving individual interest as well as the community interest as a whole. The idea behind the story was if you build the bigger vision where you can show that personal interest can multiply if the group interest is also held, has got a lot of parallels in blockchain and the themes that we are seeing today with the DAO and so on. Where if individual interest can be held back a little bit for a later time and the group interest can actually be supported for a little while longer, the individuals also will gain a lot. That we hope we can build better consensus across and collaborate better as well. Thank you.
So thank you very much. Keep these secret sauces in mind because the goal at the end of this event is that we want to collaborate on some things. I also encourage you to keep your cards. They're useful. And then finally, DAZA is collecting all of the sheets. If you did not bring up your notes, please make sure that DAZA has the sheets so we can report them. Thank you very much.
Okay, folks, we got started a little late, and I talked too long, as I usually do, and so we're running a little late. We have a break right now. Let's try to keep it to 5 to 10 minutes. So let's be back here in 7 minutes. Bathrooms are down there, down the hall, and when we come back, we will have Arvind on stage giving us a little keynote speech to inspire us all. Thank you.
And so, nobody likes a pompous keynote, and that's not what this is. Think of this as more of a conversation starter, and again, heavily influenced by the things that you've said in your position statements. So the big thing that I hope to do today is share some of my excitement for why I think there is a unique opportunity around standardization in the intersection of blockchains and the web. What the web can do for blockchains and vice versa, and in particular, how it might be possible to marry the power of blockchains with the reach of the web. I want to see if there is a way to get to that. I want to see if there is a way to democratize blockchains. I want to see if there is a way to put those two together. So that's going to be the broad theme. Before I get into that, I want to address one sort of skeptical point as well, which has come out in a couple of the position statements. Wendy made this point as well. What's ready for standardization? Where are we? Is it too premature? Right? Is it too soon? Obviously, I don't have an answer for that. Again, my role here is not to give answers, it's to start the conversation. What I do want to address is one small component of this, which is from a technical perspective, from a computer science perspective. I'm a computer scientist. One question that we can ask, and I think which is important to ask, is are Bitcoin and other blockchains sound? Are they going to be around in something similar to their present form in 10 years, 20 years? I think it's important to try to know the answer to that question to some degree of confidence as we go through this process. And that is something that, as an academic computer security researcher, as part of that community, I can bring something to the table. So one thing I want to share with you is the fact that research on Bitcoin in particular has been very, very vibrant in the academic community. This is a Google Scholar search you can do for yourself, looking at the number of papers that mention Bitcoin. The number per year now is in the thousands. It's sort of stabilizing recently, but as of 2013 or so, it's exploded. Lots of people analyzing Bitcoin. So this does not mean that all of these are papers that are totally about Bitcoin. I would estimate there are maybe couple hundred really serious papers per year about Bitcoin, people analyzing the properties of the system. By the way, why am I talking about Bitcoin here, not blockchains? Well, it turns out that from a computer science perspective, there is relatively little of substance that you can say that applies to all blockchains without being specific about which one you're talking about. And that's a point that I will come back to later in a few minutes. What does that mean for us? To what extent can we be successful in sort of abstracting away the properties of specific blockchains and addressing all of them in general? So that's one thing I want us to keep in mind. So there's been a lot of vibrant research, and academics are certainly incentivized to try to find any underlying problems with the system. A lot of people have been trying to do that. What is the result of all that? I would summarize it with about 3 points. One, I would say, is that so far, again, this is my opinion, looking at all of this research. Nobody can read 3,000 papers per year. I'm not claiming to have a perfect view of this. Oh yes, Brian Bishop has read almost 3,000 papers per year. Big kudos to him. But this is sort of my summary of what's been happening in the academic community. So I would say that there are no major fundamental problems that have been discovered so far. So again, so far as a caveat. There are certainly various known concerns. Perhaps one of the best known ones is selfish mining. Most of you may have heard about that. And it's one of maybe several other such potential problems, looming problems that have been discovered by academics as well as others in the Bitcoin research community. But one of the pieces of good news is that even though there are these problems that have been come out through a sort of a theoretical analysis, it seems that so far Bitcoin has been working a lot better in practice than it's supposed to in theory. And that's been a phenomenon that's come out over and over again. People are getting wise to that now. They're trying to refine their theoretical models in order to better model and understand and predict how Bitcoin has been working and will continue to work in practice. So this is, I would say, overall good news, and this is something positive from the point of view of standardization. In a certain sense, the underlying technology is ready, and also from a teaching perspective, let me tell you, some of you may know, me and others at Princeton did an online course on Bitcoin. 35,000 people took it, huge amount of interest. We did a textbook. So it turns out that many instructors around the world are starting to see Bitcoin as a way of introducing many crypto and computer science ideas to undergraduates and to computer science students. And so I think these ideas are going to get a lot of traction in the process of research and education. And I think we'll have a lot of resources to draw upon. So it's a healthy situation. I will offer one caveat, and that caveat is endpoint security. What do I mean by that? People getting their servers and other things hacked, losing Bitcoins, companies going down because of security issues. This is a bit different from the underlying issue of the stability of Bitcoin itself, but when it comes to endpoint security, I think the situation has been, I won't mince words here, and so far it's been pretty miserable. We all kind of know that. This just came out yesterday. This is it's called the Blockchain Graveyard. Pretty cool thing. I encourage you to look it up. This is by Magoo from Coinbase, talking about a lot of different companies and websites that went under because of security problems and what we can learn from that. So one way in which I would summarize this is that human-crypto interaction, as I call it, is an unsolved problem. Not clear if we will ever solve it for regular mainstream users to be able to handle public and private keys securely. And so I think that is one thing that we should really keep in mind during the standardization effort. Is it possible to abstract away some of those details from end users if we want to really democratize blockchains and if we want to really marry it with the power and reach of the web? I will also point out one other caveat. There's a difference both between the amount of research and the conclusions when you talk about Bitcoin versus Ethereum. Ethereum is the red line at the bottom there. Obviously, it's a much newer system, not that much research so far. But also, compared to Bitcoin, there is some amount of concern about the fundamental security of the system, both about underlying incentive misalignment issues, as I call them. What's good for individual actors in Ethereum might not be what's good for the overall health of the system. Bitcoin itself has been remarkably successful at aligning these two. With Ethereum, this is not quite so clear. There are also concerns about the ability of people to write secure contracts that we can reason about and which we can secure properly. And of course, you've all heard about or have been following in the news the story about the DAO, and that's an object lesson, I think. It's just at this point. There have been a lot of research in computer security, and Cornell is pointing out at this point. So these are things to keep in mind, but there's vibrant research both in academia and of course the is much higher than that. I'm very optimistic that it'll be in a different place in a few years, but at this point, I would say there are concerns about the stability and security of Ethereum. So now let me get to the big thing that I find very inspiring about being at this place at this time, which is, can standardization enable new applications? Sometimes we say that things like document formatting. I believe that's really important, and you can do that allows different applications to talk to each other. But sometimes standardization ends up enabling something a little bit fundamentally new. And as an example, I would give the introduction of cookies to the web. And standardization coupled with a little bit of browser functionality, fairly trivial functionality, sending the cookie to the server every time you declare the server, but fundamentally also the character of the web. It made a lot of new applications possible, both for good and bad. It has some negative effects as well. That is something to keep in mind. I want to say that's sort of opportunity that we can exploit in the blockchain world when we combine it. Possible. With standardization, add a little bit of browser functionality, enable something. Is that possible? So I'm going to give you one example of this where I think this might be possible. I'm not saying this is the one thing we should focus on by any means, but it's just meant to act as a, to prove the point that something like this might be within our reach. Imagine, I want you to imagine 5 to 10 years in the future, a user, either through a web browser or let's say even an IoT device that's web enabled. What they're trying to do is they're interacting with some server or a service provider. And what they're saying is basically issuing a command to do something on the blockchain. What I mean by do this, I will make that more concrete in a moment. The key thing I want to point out is that it's an untrusted server. The client is not trusting the server, and I want to point out that this is a thin client, which I've noted in my figure. So as many of you are familiar with the notion of Bitcoin thin clients, I'm sort of generalizing that notion. The client doesn't have much functionality in general, really wants to rely on the server, but doesn't want it. Now the server carries out that task, but in addition, it does this one key thing which is enabled by the blockchain, which is, it says, I've done that, and here is the proof. And this notion of proof, as many of you know, is one of the cool things that blockchain enables, cryptographic proofs that the client can verify. And I'm going to claim that this is really important, something that we should keep in mind in the standardization. Why does this enable powerful things? Imagine in this vision of the future, the browser over here, just like a secure site today, shows a green lock in the browser address bar, and the user doesn't need to know much else, basically handles the verification of the proof. And the user is happy and convinced that whatever action they gave, whatever command they issued, has been successfully completed on the blockchain. Imagine what that world would enable. A lot of different applications. And again, I read all of your position statements. Many different threads of applications came out of that. things like contracts, not even talking about smart contracts at this point, just legal contracts that we might want to timestamp right on the blockchain, just basic document timestamping. Provenance, both for creative content as well as for IP and assets and so on. Lots of people excited about IoT. I read decision statements from IBM and BT and so on. And again, identity was another really important final thread here. So think about any of these applications. Let's say, think about, for example, you're renting an apartment, you walk into the landlord, you have a thin client over here, the landlord's computer connects to some backend server, which is connected to the blockchain. You sign the document, and where's that music coming from? Is that my phone? Somebody's phone here has an alarm going on. I don't know if you know whose it is. It'd be nice to. For the moment, yeah, I tried to cancel it, not working. Okay, thank you. So imagine you do this and your landlord timestamps that onto the blockchain and sends beams through Bluetooth or whatever that proof to your mobile phone. And your mobile phone, being a thin client, not being a node on the Bitcoin network, is still able to, through your mobile apps or browser's trusted interface, web-based interface, is able to convince you, the user, that the landlord has done this correctly and that the document that you just signed has been timestamped onto the blockchain. You can imagine a similar thing for in the identity space, for creative content, for whatever you want. So I claim that this sort of model, if we can enable it through standards, is going to be a way to combine the power of the blockchain with the reach of the web. Because this enables use of the blockchain to anybody with just a web browser without having to interact directly with the underlying crypto. And what the standardization process would have to deal with here is thinking about what this means and what is the language for that and what is the set of things we want to be able to express. And in the reverse direction, when the server sends a proof back to the client, what does that proof mean? Who's going to verify it? Is that in the browser? Is that a browser add-on? What is the user interface for confirming to the user that the proof has been correctly verified and so on? So there's a little bit of work that we have to do to figure out exactly how to operationalize this. But if we can, my feeling is that the power that this is going to unlock is going to be really tremendous. And today, with or without standards, I don't think we have anything quite like this that is possible. And just as an aside, I want to make a quick technical point. When I say proofs here, what do I mean? And I want to show you a simple example, a technical example of how one of these proofs work. Let me show you the simplest possible proof, where the client simply says to the server to put a specific piece of data onto the blockchain, and the server sends back the proof. So what does this look like? Visually, what's going to happen is this is what the blockchain looks like. You've all seen Merkle trees that are connected together by these hash pointers in different blocks. And the piece of data that you want to write onto the blockchain is going to be one of the nodes in this tree. So it's going to be this node over here, for example. Now, what does it mean for the server to prove to you that it has written this data into the blockchain? Many of you may have seen this, but if you haven't seen it, this is what I mean by efficient proofs. This is the data structure called Merkle trees, and this is what is enabled. What the server can give you is only these pieces of data that are highlighted here. You don't have to care about most of the currently 70 gigabytes in the blockchain. You only have to care about a very small, in computer science terms, logarithmic amount of data. And this will enable any simple dumb client to verify by following these cryptographic hash pointers and by looking at the proofs of work and checking for 6 confirmations whenever you want to check that the piece of data you're interested in has been written to the blockchain by the server that you don't even trust. Right? That's the magic that it enables. The server does all the work, you don't trust the server, yet you can be cryptographically convinced that it's acting correctly. Let me give you one other example. Identity has been a huge topic here. I know a lot of you are interested in that. Let's say another slightly different scenario. The client wants to ask the server a question, the client has a particular user, a friend, let's say in mind. The client knows the friend's handle, wants to ask what is the public key. The server can say, here's the answer, you can verify this yourself. And what I want to envision, what I think we can make possible, is I'm borrowing here a graphic from Blockchain B, which is one of the identity efforts. There are many of these, but they have this nice graphic, so I borrowed it here. So imagine if the server could send some representation of this identity information back to the client, and the client's trusted interface, web-based interface, verifies all of this information, and so the client can simply trust that what they're seeing reflects what's actually on the blockchain. I think we should be able to enable that. So in other words, what I'm saying here is that standardization could be a way to bypass this messy process of human crypto interaction and sort of the term that I like to use, of users manually having to know what public-private keys are, having to check signatures, so on and so forth. Let me give you one other technical example of a slightly more complex proof because I think it illustrates an important point. Now, here, this is the sort of thing that you can imagine in a system like Namecoin, if some of you know about that. So the client could ask, what is the IP address corresponding to a particular domain name? So this is a blockchain-based domain name system. It's a replacement for the centralized ICANN-based domain name system. The client asks the server, what is the IP address for this domain name? The server says, here is a record, here's a transaction record that maps this domain name, example.bit. .bit is an alternative hierarchy for Namecoin-based domain names, to this particular IP address, XXYYZZ. Now, do you think it's enough? Do you think it is sufficient if the server approves the statement over here to the client, for the clients to be convinced that XYZZ is the IP address that it wants? No, exactly. Because that domain name might have changed hands, there might be a newer record, so the server also has to prove this additional statement saying there is no future record after this record that that concerns this particular example.bit domain. So you can see this is a more complex notion of a proof. This won't fit into the simple Merkle tree-based proof that I showed in the previous slide. So this leads to, if we want to enable a broader set of applications, leads to a very interesting set of questions for standardization. Should we standardize a specific small set of proofs? This is similar to Bitcoin's approach of whitelisting impunitive scripts. Or should we standardize a language for proofs, similar to Ethereum's approach of having a Turing-complete system? And I know that many of you have thought about this. I read this proposal for fiduciary signatures, where the authors have clearly done a lot of thinking for these language proofs. Again, a lot of great ideas. I don't have any answers here, but these are, I think, important questions that we should address. Let's take this a little bit farther. Let me show you just how much potential there is here that can be unlocked. I want to claim that in this scenario, verifiers could even be offline. Think about a typical IoT space. In this one, I'm using the example of a car that can be opened by a digital key. I want to say that we can enable the following scenario. If you want to, for example, loan your car to your friend for a period of a day, what you could do in this hypothetical world is they could have a USB-based car key, and luckily I was able to find a graphic for that. It's a car key with a USB port, into which you can upload some information pertaining protocol that might happen in this scenario. The card queries the key and asks, who are you? And the key says, never mind who I am. Here is a proof, here's a cryptographic proof that shows that I'm authorized to drive you for some period of time, starting at some point, etc., etc. And the car can verify this using information, including proof of work and so on. Now, I do want to point out a caveat that if you go to this offline model, you're losing certain security properties. You go into a weaker security model. And I know that there are people who are even uncomfortable with the notion of thin Bitcoin clients instead of full-fledged Bitcoin clients in terms of slightly weaker security properties. But my position on this is that the opportunity here is just so enormous that we should try to identify and fix the security issues and improve the security properties instead of going away from the scenario altogether. And I will admit, I'm a little bit biased here. So the win here for me is not having to put internet in not just cars, but also toasters in every little IoT device in order to have it interoperate with the blockchain. What if we could do it without having to do that, either without having to even connect it, or at a minimum, only putting a thin client onto those devices? I'm sure that most of you follow the Internet of Shit Twitter account, has been cataloging all of the things that have been going disastrously wrong in the last couple of years with putting a chip and full internet access into toasters and everything else. If you don't follow this, by the way, forget about my talk. You should go follow Internet of Shit right now. That's the most important thing that you'll learn from this talk. But my take on this is that standards can be a way to keep these clients thin and dumb, and I'm using both of those in sort of and technical senses here. I know that a lot of companies here are interested in IoT and marrying that with the blockchain. I'd love to hear your take on what you think is the right approach here. So I want to make a couple of more points. This was the primary idea that I wanted to communicate this opportunity here. But I want to make a couple more points. And one is that it matters which blockchain we're talking about. Because, let's go back to this visual. Imagine this notion of the client telling the server to do something on the blockchain, and the server communicates back a proof. Even if it is the case that different ledgers are able to do roughly the same set of things, or you can identify a subset of things that most do, even if you can standardize this part, the word this here, this word proof down here is going to be pretty difficult to standardize across different ledgers. And if you don't do that, then you've only solved half of the problem. And let me explain what I mean by that. So this part is going to really depend on the blockchain. And one example of where this really comes into play is public versus private blockchains. So why is this the case? Let me permit me for a moment to sort of deconstruct private blockchains here. I'm going to use private blockchains interchangeably with permission ledgers. And if any of you use them in a different sense, I'd love to know, but for me, they're going to be the same. So what do private blockchains have in common? What do they have different from compared to Bitcoin's blockchain, for example? They keep the notion of an append-only log using hash pointers and Merkle trees that I showed you in a previous graphic. They keep the notion of cryptographic identity. They throw away the notion of proof of work. Obviously, private blockchains don't need that. They throw away this cool Nakamoto consensus concept, which is one of the primary innovations behind Bitcoin. And of course, they dispense with the need for a currency. And a lot of different private blockchains have also gone back to this notion of Byzantine consensus protocols, which go back in the computer science literature to the, I want to say the 1980s. I'm not exactly sure, but it's many decades ago. The point I want to make here is that, this is a different technical configuration. Most of the technical components, or all of the technical components that exist in private blockchains, go back decades in the computer science literature. I mean, this idea of Merkle trees, people were putting roots of Merkle trees in the newspaper before anybody had heard of the blockchain. This is a company called Guardtime that collects documents from its clients, enterprise clients, compiles them into a Merkle tree of hashes, and puts the root hash as an advertisement in the newspaper so that it's published for all the world to see. So every idea that's in private blockchains actually has a pedigree going back really for decades. Now, why am I saying this? So I want to also point out to one really funny tweet that to me really explains why private blockchains have been so successful. This person argues that they've been sort of a stone soup for capital markets technologies. In other words, it's the buzz around Bitcoin and its blockchain that have brought all these banks and all these entities to the table to discuss this new set of, or supposedly new set of technologies, whereas all the underlying actual technical components behind private blockchains really go back to the 90s and 80s in the computer science literature. Why am I saying this? I'm saying this because private blockchains have dispensed with proof of work, with Nakamoto consensus. That means this component here, what the blockchain is going to be able to prove to you about its operation, is totally different from public and private blockchains. It's going to be totally different for Ethereum, or if you look at some other blockchain that's over there. So this is something we should keep in mind. A number of different commenters, I believe from Hyperledger, Digital Bazaar, IPFS, have proposed this notion of interlinking different ledgers together. I think that is good, that is important, we should do that. I do also want us to keep in mind that they have vastly different security properties, so we should think about what happens when we link or combine them, what happens to the security. That's a notion that I want to bring to the fore here. I only have a couple of minutes, so let me jump to my last point here, which is a note of caution. If you've heard me speak on this topic before, you knew I was going to get to this, but often there is a tendency in the blockchain world to sort of jump too far and try to seek technical solutions to social problems. You've all seen this. I see nods in the audience. I don't even have to explain it. So I want to offer a note of caution on that. Instead of me explaining it, I want to just read one quote from Angela Walsh from one of the submissions. I did tell you I read all of the submissions that were posted on the website. She says, when messing with medicine or property records or finance, you're dealing with the lives and resources of individuals. This is exciting, but it also carries a heavy responsibility. Right? This is something I want to urge us to keep in mind. And the reason I'm bringing this up is that here's the new thing I want to say. I want to suggest that standardization can actually act as a key check in this process of sort of preventing us from trying to seek technical solutions to social problems. It can do that in many ways, and because it offers an opportunity for introspection to ask us, is this technology that we're putting on a pedestal and which we're standardizing, is that going to be applicable the world over? Is it the right one for everyone? What are the benefits? What are also the costs? Can we think critically about the potential harms of this technology? Standardization forces us to do that. It also acts as a point of regulation for how we want to use this technology. And finally, it imparts legibility. Some of you may know this term from books like Seeing Like the State. What I mean here is standardization, while it's primarily a process of getting computers to communicate with each other, the process of documenting and specifying what we're doing also allows the technology to be legible, so to speak, to people like lawyers, to people like regulators, who want to come in and have a discussion about how we're using this technology in our social world. And so I know that today, these 2 days are days for technical discussion, but in terms of the broader standardization process, I would love for us to keep this in mind. And I would love for technologists to reach across the table and use this as an opportunity to think critically about the place of blockchains in our society. And with that, I'll just put here the takeaway and points for discussion throughout my talk. I won't repeat them, and I'll end here. Thank you very much.
Arvin, thank you so much. Marta, are you here? Do you want to come on up? Marta is going to be the host for the identity lightning talks, and everybody who's doing an identity lightning talk, have you talked to them already? Is Vladimir here? Okay. If he gets here in time, I guess he can do a lightning talk. Daniel, I guess you're first.
For everyone who will be doing the lightning talk, please introduce yourself first and say where you're coming from, what's your background, and like 3 sentences about yourself so we know something about you before you talk. And you have 5 minutes to give your lightning talk, so that's it.
So my name is Daniel Buckner. I work at Microsoft. Specifically, I work on blockchain identity systems and building around it. It's a really important piece of any of the blockchain work that I think everyone does. So here is the presentation. So I think really what blockchain can enable is a few key things. Identity is huge. I really think it's going to transform our world, create a web that's bigger than anything we've seen, bigger than sites, bigger than FTP and files, bigger than all these present use cases. It's going to come to define the fabric of how everything interacts with each other in the world. So blockchain, people say, what is blockchain? Well, it's really, it's a lot of things that already exist, right? Like it's easy to dismiss because, we've had cryptography and, peer-to-peer networks are here. Sean Parker is, growing gray hair now. And consensus algorithms aren't new. There's maybe a new riff inside of this particular protocol. But really it's because of these things being put together in this delightful package, right? It's a lot like Apple does when they take, first created the iPhone, right? Touchscreens existed, technically apps were on other platforms. All these things existed in constituent parts, but what they did was bring them together in a way that was delightful. So you prove that you own these tokens, whatever you want to value them as or have them stand for. It's decentralized and distributed. And most importantly, it's a proof of ownership that's secure. So, cryptographically secure transactions synced over a worldwide network, global ledger, a chronological state of ownership for every participant involved in the system. And that's important because those are the same qualifications we'll need for something else called identity. What is that? Well, identity is a collection of attributes, activities, and interactions provably linked to an entity. So the brass tacks, there's a lot of stuff out there about, what do we need for identity? Chris Fallon out there, he has these 10 facets. They're very technical facets for what an identity is comprised. Be it, user sovereign. You have Kim Cameron at Microsoft, you find the 7 laws. This is more of a product-centric view. So what we need to really enable the decentralized apps, services, all sorts of other stuff that we need out of this system? Well, it has to be an open system. Microsoft can't go create another proprietary thing and say, great, here's the identity for the world. I don't think anyone's going to listen to us. It's got to be user sovereign, so it can't be touchable by bad actors, entities, even the greatest government. Like the best people can't be trusted to own you. So it has to be something that's owned by the people. It's memorable identifiers, huge important piece. We can argue that we want complete anonymity, and while I believe that that's important, it's also important that memorable identifiers can be created. Because when I'm walking around at a conference looking at people's lanyards, I'm not going to be memorizing a 32-bit integer. Indexable registry. So I should be able to register these identifiers in a single place. When I can look to one place to say, I know his name was Dan, or Dan.id, whatever that identifier is, I need to be able to go find it. I need to know where I'm going to find it. And then obviously semantic data. So the thing at the other end of that identity must be semantic. I have to understand what the machines. So when I reach out and grab it, everyone's identity is different from another. So here's the first claim. The identity opportunity blockchain presents is historic and unprecedented. Why is that? Well, we've had signed data backed by public-private keys for a long, long time. But when you add that to what we already talked about blockchain being, which was this proof of ownership, we can start registering transactions on a blockchain that reserve names. And that becomes interesting because, I can't. So once you can start registering names, essentially co-opting the transactions on a blockchain to do this, you can build links out to identity data and then a registry of that data. So I could essentially build a name system, which is incredibly important because this name system is unowned. Second claim, an open user-sovereign global identity system will be integrated with almost every product, service, object, inanimate object, and human activity you can possibly imagine. And this includes use cases like licenses, agreements, documentation, attestation, real-time data. And here's probably the most wild claim. I truly believe that the data that comprises all those use cases I just listed will not live in any fashion on the blockchain. People talk about the source data in the blockchain. They talk about generating a Merkle hash and putting the hash in the blockchain. All those things are irrelevant. Instead, they'll be enabled and anchored by blockchain identities. We know there's a scale problem with blockchains. There is, and it's for a reason. It's for a good reason. So there might be a better way. So let's take a look at one example. I have a person, Jane, she's going to buy a car. There's a lender involved and a saleswoman. So the normal way that this would be done in a lot of these blockchain scenarios, what people aspire to, is they create some sort of loan object and they have the source data. You have to keep it because if there's ever a dispute for the loan, you say, well, what's on line 9, character 4, right? I have to actually be able to go look up the loan. A hash doesn't do me anything, right? Like if I take a hash of that and put it on a blockchain and I lose the source material, guess what it's worth? Nothing, right? Like if someone disputes that loan, they have to produce it. So you get nothing. So it's important to remember that. So instead do this. Have everyone in the system, even the car itself, have a blockchain-based identity. When the dealership generates that loan object, Jane, it's generated by the saleswoman, she signs it. The lender, Bill, he signs it with his blockchain identity. Jane agrees to those terms, so she signs the object with her blockchain identity. Understand that nothing that occurred here happened on the blockchain. They're identities that are rooted in the blockchain, so they waterfall that trust, right? So I'm signing these objects, and in the end, I give a copy of this multi-signed object to everyone in the group, and at any point in the future, they can bear that object to prove multiple things. It contains the source. It contains a verification of everyone that agreed to it, and it's provable. And the result here is the point of all this, and where I think we want to head with identity, and hope you will join us with, is that we can enable line speeds. We can enable things at line speed with identity without clogging a blockchain that are enabled by a blockchain. I think it's something incredibly important to keep in your mind as you're listening to use cases over the next 2 days and all the systems that people are going to talk about. Maybe there's a really efficient way to do it. I think it's through identity.
Next will be Thomas Harjano, talking about self-source verifiable identities for future blockchains. And as Thomas is setting up, I wanted to just tell you that we decided to talk about identity first. I'm not sure if Doug talked about it, because as the steering committee, we really believe that identity is one of the most important issues, or something that would span in our conversations throughout the whole 2 days. So we wanted to kind of get get it out of the way as one of the biggest issues of the blockchain. We hope that you'd agree with us, and that's why this is like the first series of lightning talks that we'll have. We will later on move to the other big issues that we'll deal with on the blockchain. So,
folks. Just a quick intro. I work in the group of MIT Connection Science. You can see a few faces from the group here. But anyway, I'm going to talk about identity, trust, and data, which is the three things that are inseparable. So, people like to talk about identity. Great, I'm big on that. Been doing that for almost 2 decades. There's the issue of trust, and there's also the issue of data. And data could mean data is in raw data. It could mean metadata about identities. So it's a lightning talk, so I'm just going to do like 4 or 5 slides. So the big question is, does blockchain technology solve the following 3 things that we care about? So the identity problem. So does it help us with this question of the quality of an identity system, or specifically the security of a digital representation of an identity? Does it help us indicate the degree of freedom of independence that an identity has? So we love to talk about self-sovereign identities, but how do you measure that? How sovereign is an identity? What's the gating factor? What's the source of an identity? So I could argue that the source of my identity is my parents. So a baby doesn't get to say what his or her identity is going to be. It's always your parents. In fact, in traditional societies, it's a community decision, right? So the parents might say, well, here's my new baby, name is Joe Blow. You live in a village, great. The village is going to be the entity that's going to attest to that name henceforth. So if you look at traditional societies, you see people's last names are usually the village name, Joe from whatever, Cambridge, right? And when Joe Cambridge goes to, to meet, Bill Newton from Newton Village, right? There's something going on there, right? So it's not all straightforward. So that's an issue. So there's an issue with, I'm just going to list a whole bunch of, questions I have about this issue of privacy, binding to real-world attributes and reputations, the provenance of an identity, the trustworthiness, availability and persistence. So if you're using an identity, a digital identity, to transact today, who's going to archive it? If you get called to question, 10 years from now, it's going to be available. Is it reputable, not reputable? If I'm transacting with it, and I lose the key, what's going to happen? Right? So these are all classic problems. So does blockchain solve the data problem, right? So this is the other side. So this is the pain point. Just looking at the industry today, this data loss prevention (DLP) industry that have just grown in the past 5 years. People know what I'm talking about. DLP, heard of it? If you haven't, don't worry about it. So organizations are holding massive amounts of data, right? Which is great. People want to do analytics. People running Hadoop infrastructures and Spark infrastructures. They want to have the terabytes of data in their premise. Well, guess what? That doesn't scale. You can't share data across institutions. There are regulatory limitations, transporter issues, and so on. But just for individual enterprises holding user data, they are a great attraction for hackers. People remember the Anthem database, so nothing was lost, but a whole bunch of records were copied, right? And so, how do you solve this issue? What is the ownership of data? So there are now, in fact, organizations, particularly in Europe, who are saying, end user, here's your data. You can take it back because we don't want the liability. So how does blockchain technology help this? How does blockchain technology allow metadata to be indexed in search? Does that help? These are issues. The trust problem. So this is the hard part, right? When you come to talk about digital identities, it's a trust problem. The digital identities. I like to talk about technical trust and social trust. Technical trust is a big thing in trusted computing because technical trust basically implements cryptography. And I like to say, in cryptography, we trust. People know that phrase, right? That just gives you technical trust. It doesn't give you legal trust. It doesn't give you social trust. Social trust is most often encoded as legal, right? So people who are working in the identity space would know what a legal trust framework is for identity. So we need to solve that problem. We need to standardize. If there's anything that needs to be standardized, it would be a legal trust framework for identity sharing and for data sharing. These do not really exist. Identity, yes, but definitely not data sharing. Trustless is not equivalent to trustworthy. Decentralization doesn't map automatically to trust, right? Just because something's on a blockchain, it doesn't mean you trust it. There's a social trust, there's a legal trust. Finally, we have the thing called, we have another problem, which is the privacy problem. So our group at MIT here is working on a new paradigm based on these three principles of thought. You never allow raw data to leave your repository. Right? This is breaking out the Hadoop model. Big data analytics role will need to change. Data needs to be encrypted at all times. That means data in operation or at rest must be encrypted. This is why people are spending a lot of time on homomorphic encryption. This is why MIT Enigma, the Enigma project, is gaining a lot of interest because it provides an avenue for a solution. Always return aggregate answers. Right? So these are the three principles. We think that blockchain technology, peer-to-peer nodes, will have a role, particularly for something like Enigma, where you have a distributed repository always encrypted, where you can actually run queries over the encrypted nodes. Okay, that was like it.
Thank you, Thomas. Okay, Vladimir has arrived or not? I guess not. Then Ryan, are you here? Yes, you are. Wonderful. So Ryan will talk about self-sovereign identity with Blockstack and Block.
Hi everyone, good to be here. Good to see you all. Okay, here we go. So my name is Ryan Shea, and I'm with Blockstack. And how many of you have heard of Blockstack? Who here knows? Cool, awesome. And who here knows one name? Okay, cool. So I'm with an open source movement called Blockstack. The company that I work for is called Blockstack Labs, and we work on the protocol and contribute. And we also created an consumer application called OneName. And just a little bit more about who we are. So this is our core team. It's myself. The size, the font size. Yeah. Let's see. I can't really. It's not. You don't have to read it. I'll make sure in the future slides that the font size is bigger. So that's me, my co-founder Manib, Guy, and Jude. We have 2 computer science PhDs from Princeton. We also have 2 Princeton professors as advisors, and who've worked on the P2P systems for decades. We are the most popular, most used layer 2 protocol on the Bitcoin blockchain. That means outside of Bitcoin for financial transactions, Blockstack transactions represent the largest system on top of the Bitcoin blockchain. And because the Bitcoin blockchain really it's the only blockchain with meaningful use, that also means that it's the most used protocol across all blockchains. This is an older graphic, but this is basically the growth of identity registrations over time. It has since surpassed this, but we continuously get new registrations, and so we are we actually represent, Blockstack represents one of the largest systems to date. But that's just a little quick introduction. I want to shift gears and talk about digital identity for a second. So when we talk about digital identity, we can refer to many different things. I think people often are referring to people, but it can also refer to organizations, devices, and ideas, right? In the sense, money is an idea, right? But I want to focus on people right now. And when we're talking about identity, there's kind of two interrelated concepts that we're talking about. One is this idea of entity persistence, and another is a bundle of attributes. So with entity persistence, all you care about is this is the same thing that I was referring to before, this is the same thing that I saw before. Once you have entity persistence, you can actually build bundles of attributes on top of those persistent entities. Oftentimes, we don't actually have true entity persistence, and so what we do is we use the bundles of attributes as a proxy to inform this entity persistence. So for example, if I go out and leave the room and I come back, you might not know I'm the same person, but you look at my physical features and deduce that I'm the same person. But if I had a twin, I could actually be a different person. So because you don't have that continuity of observation of something, then we actually don't have true entity persistence in the real world unless we have unless we have cameras everywhere. But what's really interesting is with the blockchain, we can actually get true entity persistence. In the digital identity world, we can get entity persistence by through digital keys, right? So long as that key system doesn't get broken. And we can also have users sign challenges with their keys to prove, to continuously authenticate throughout time. And then when it comes to bundles of attributes, users can sign statements about themselves, and then other people can sign statements about them. And there are multiple entities that can corroborate these statements. So I'm going to introduce a few concepts here. First, I'm going to say that when a user owns an account and there's no context around that account, I'm just going to refer to that as basic identity. If there are self-attested attributes, I'm going to call that contextual identity. And then if there's attestations from trusted parties, then we can refer to that as a level of verified identity. And if it's managed by the person's digital keys, then we can say that it is self-sovereign identity, as in the user has sovereignty over themselves. So we move on to identity with the blockchain. And we can ask ourselves, well, why do we actually need a blockchain for this? And the reasons for that are, one, we want to build an identity system that's as global and universal as the internet. We want something that supports secure information transfer, and we want it to be resilient. We want it to be free from identity theft and social engineering. And various properties of the blockchain can allow us to achieve that. Certain things belong on the blockchain, certain things don't. Digital keys, domain names, pointers, and hashes belong on the blockchain. Things that don't belong on the blockchain are both public and private user data, self-signed attestations, and third-party attestations. Let's get through this. So going back to Blockstack real quick, we have, as I mentioned before, there is this Blockstack network that operates as a layer on top of Bitcoin, and there are multiple clients that operate on top. So this is kind of how we thought of it in terms of building a truly decentralized system for naming and identity and public key infrastructure. Let's get past this. Yep. And so I want to go into, in the last section, what the power of blockchain identity is and what it can enable. So blockchain identities can replace passports, driver's licenses, student ID cards, social security numbers, passwords, Facebook, Twitter, Google login, physical keys and key cards, security questions. If we really want to have a universal identity that can be used in all kinds of different contexts, with privacy features, of course, and with features where you can, do a minimal disclosure proof that you actually have authorization to access something, then we can say that it's more convenient for the user if we can have something that works across all different contexts. Blockchain identities can be useful in financial services, healthcare, government services, Internet of Things, armed forces. We really have the potential to create something that is truly universal, is powerful, is it's similar to how email and password. The email and password is a fairly universal identity system, but it is very primitive and has lots of problems. So if we want something that is similar to that in its universality, but has a lot more capabilities and a lot more security, then we need something that that is an open standard and is on an open platform, and that's where blockchain identity comes in, and that's why it's that's Chance. You can check this out if you want more information on it. And thank you guys very much.
So, our final speaker is Adrian Roper that will talk about self-sovereign support technology. And yeah, he'll talk more about that. His introduction is very long.
Okay, so I'm going to describe a pilot that we're working on to demonstrate self-sovereign support technology and decentralized ID for a medical prescription in the regulated and real-world sense. I participate in standards and policy development from the privacy engineering perspective, and so in effect, I'm sort of I loved Arvin's takeaway about what we're doing here in terms of both standards and real social impact. So what we're trying to do is to use the blockchain to reduce the liability of the institutional participants while promoting innovation overall in the system. And so what you're looking at here is that a medical prescription involves four parties, two self-sovereign individuals, a physician, and two institutions. In this case, the pharmacy, which is a regulated institution. It could be a vendor, regulated by the FDA or the DEA or anything, and the medical society, which is in effect managing, is an institution managing the license of the physician or standing for that. If we go to basically the patient is accountable, the MD is licensed, the medical society is authoritative, and the pharmacy is regulated. So if we can pilot and demonstrate standards and how this would work in real life, I think this is a reasonably broad use case for what's going on here. As I've said, the goal is to reduce the liabilities of all parties, and Thomas made that point himself. The blockchain removes the middleman in this case. Right now, we're used to having something like a hospital that accredits both the physician and identifies the patient. And in effect, that becomes a drag on innovation in the overall sense. So the idea is to show as this proof of concept, pilot the standards for self-sovereign technology, particularly in the case of the technology that's used by the physician and the patient to interact with each other. And it basically will involve three core standards: the distributed ID, the authorization for how personal information moves from one place to another, and a transaction hash as a digital postmark in order to deal with the compliance issues and the disputes that might arise. And so finally, there's a Bitly address there that stands for self-sovereign support technology and distributed ID, where you can find more details about what's going on. Thank you.
So Vladimir, have you showed up? I guess not. So these are all lightning talks on identity. I guess we'll move to the
So, is there anyone? So, are people satisfied with these as sort of the topic areas, or does anyone else have a topic area and identity that they'd like to form a topic table about? Anyone? Just one second.
Sorry, I didn't hear this explicitly spelled out. There's a bit of work going on in the Verifiable Claims Task Force at W3C. I'm sorry, around verifiable claims. So the question is, how are we supposed to express statements around identity? And there's specific work happening right now to try and start a standards track thing. Right, it's very experimental, pre-standards, but I think we should probably be at the table on that.
So one thing that I didn't hear was how efficiently can we verify identities using the blockchain. So it's actually very easy to lie without forking the blockchain. We're just putting two identities in the chain and then showing them Merkle proof. But it turns out, that's not a non-membership proof. So I would like to see some discussion about efficient identity using the blockchain. So thin clients.
Hi, I'm not sure if it's separate or not. It just seemed like a slightly different use case from, say, the medical one. Is we're interested in identity from the point of view of education and educational recognition. So I don't know if anyone else is interested to talk about that.
Thank you. I think I'm not sure how many of you have heard about the large-scale experiment or project going on in India about a universal identity, where the iris scan of people is taken and you get a card with your QR code with your identity on it. My key challenge from a people perspective is the acquisition and creating of that identity. Specifically, these people are going into remote places, having small kids, and providing identity to illiterate people who can't even read and write and still should be or having the capability of opening an account. And how do we get out there? How do we ensure that we can propagate the identity process, not just in developed countries or countries having access to all kinds of teams with which this can be created, but how do we take it across to 7 billion people, or maybe 5 billion of those who do not have this kind of an access?
My name is Jay, and we're working on Tendermint, which is a blockchain consensus engine. It's mostly known in the private blockchain space, but we would argue that it can also work in the public space with a proof of stake overlay. But anyways, the point is that using classical Byzantine fault-tolerant consensus, using cryptographic public keys as identity for securing the chain, you can get much better light client proofs. So if anybody wants to talk about better proof systems like we were talking about in the intro.
Okay, anyone else on identity?
Hi, I'm Joshua from BT. We spoke about identity, and the fact is identity management systems has identification, authentication, and then there is authorization as well. So something we've been looking at is for example, to put identity in context, that the verification is good if you have, say, biometrics in localized form, and identity management systems do that quite well. So we've been exploring how to do authorization as an interoperability layer between identity management systems and security company systems. So I would like some discussion if it's interesting.
So what we're doing, so listen to these topics. If any of these interest you more than we're going to have a topic table for each one of the topics that comes up. If any of them interest you, just keep in mind which one you want to go to.
Yeah, I'll also ask people who just stood up and talked about things that they would like to talk about to start moving towards the front so that we'll see them and we'll just start like forming groups or whatever. It'll be easier that way. I'll give you, and we'll try probably merging some of the topics together. I will throw in one thing, which is what is the minimum set of things that belongs to identity on the blockchain?
I just want to clarify, if I was to do a table, hopefully participate in the table, the subject I really like to talk about is taking all these things off chain. Like all these things that you see that you want to put on chain, how do you do it with identity and that specifically? So I lead the Hyperledger Identity Working Group, and in about 15 minutes, there's a conference call where IBM is going to be presenting about membership services. So if you are interested in Hyperledger or IBM's membership services, we have a separate room for people who might want to come in there and capture their thoughts around Hyperledger's identity system. Purely optional, and we have a room for it outside. I'm sorry. Okay, so Hyperledger has one proposal, which is IBM's Fabric. IBM's Fabric has a unique identity architecture with some of its own cryptographic primitives that IBM has not been really clear about the architecture, about how it works. Today is the day that they're announcing how it works and all of that. So if you're interested, if you've got a deep commitment to the Hyperledger project, you may want to come in and join this thing. And it'll end at the same time as these breakouts do. Follow me.
If you're interested in, follow Christian. If you're interested in any of these topics, go to the person that you're interested in.
Okay, so now people who want to do a table discussion and have something to talk about or had an idea, please move towards the front of the room. So all the people who gave lightning talks or stood up and held the microphone for 30 seconds, please move towards the front of the room. Now, I will pass the mic and please summarize in 5 words or less okay, 2 sentences, what you wanted to talk about, and if you think that you can merge with someone who was talking before or after you, please merge so that we can actually have working groups and not 3 people at the table. Yes, good idea, thank you.
Well, a simple topic to say, which is, how do we get this identity across to more people in the world?
We have a proof of concept now for the patients and physicians to use. It doesn't have a blockchain component in it, and this pilot that I was talking about is to add the blockchain component and turn this into a legal pilot, into a real pilot.
So I guess medical application, blockchain on medical application.
Amazing like client, Merkle proofs, or proofs in general for identity.
Verifying identity.